Okay, how do we solve equations with two radicals? Okay, the first problem that we see here, both radicals are on the same side of the equation. My first step here is going to be to get a radical on each side of the equation. So I'm going to leave this positive square root of 2x plus 5 on this left side, and I'll add the square root of x plus 7 to the other side. Now that I have just two radicals, there's no extra numbers, and there's a phone. Alright, sorry. Since there's just two roots, there's no extra numbers or anything, we can just square both sides. Squaring a square root knocks off the square root. If these were both cube roots, what would you do to both sides? Cube them. Would that change anything? No, because all it's doing is knocking off those radicals. So now I have 2x plus 5 is equal to x plus 7. Right? I need to get my x's on one side and my constants on the other. So I'm going to subtract an x from each side, and I'm going to subtract the 5 from both sides. I have an x equals 7 minus 5 is 2. Alright, but we're not done with the problem because we have to remember to check for extraneous solutions. Okay? So, to check, we just plug it right back in. Let's see. It would be 2 times 2 plus 5 minus the square root of 2 plus 7 equals 0. So, square root of 2 times 2 is 4, plus 5 is 9, minus the square root of 9 equals 0. Square root of 9 minus square root of 9 equals 0. Yeah, that works. X equals 2 is my solution. Alright, in this example, we have a radical on each side of the equation already, but we also have this extra negative 2 hanging out. And that makes things like a little bit more complicated. Okay? Once we have the radicals on each side of the equation, we can start the whole thing the same way as we did the last problem. We're going to start by squaring both sides. I have the square root of x plus 6 minus 2 times the square root of x plus 6 minus 2 equals, and then this side, the square root squared, just the inside of the radical comes out, so equals x minus 2. Because we squared a binomial that we have to write it out twice, and now we FOIL. Okay? So let's FOIL this. The square root of x plus 6 times the square root of x plus 6. That's the same thing as the square root of x plus 6 squared, so that's just x plus 6. Now, the square root of x plus 6 times negative 2 is negative 2 times the square root of x plus 6. So, now we go to the negative 2. Negative 2 times the square root of x plus 6 is the same thing that we just wrote down. Negative 2 square roots of x plus 6. And then finally, negative 2 times negative 2 is positive 4. And all of this equals x minus 2. We're going to take everything on the left side and we're going to combine like terms. Now, just like with any of these, if I'm going to solve for x, first thing I need to do is isolate this root. So I'm going to get rid of this x, this 10, and this negative 4. So I start by subtracting an x from each side. That actually cancels all the x's that aren't inside the radical. Then I'll subtract 10. So as of right now, I'm at negative 4 square roots of x plus 6 equals negative 12. I'm still not isolated. I have to get rid of this negative 4 by dividing. And I have that the square root of x plus 6 equals 3. To get rid of that square root, now I'm going to square both sides. So x plus 6 equals 9. Subtract 6 from each side, and x equals 3. Now I'm not done because I need to check that this is if this is extraneous. So I'm going to check 3. The square root of 3 plus 6, that's the square root of 9 minus 2 equals the square root of 1. 3 minus 2 equals 1. That checks out. x equals 3 is my solution. All right, in this last example, we have a radical on each side. We also have this plus 1 hanging out. So we're going to start this the exact same way as last time. We're going to square both sides. So on the left side, I'm going to have to write that out twice. The square root of x plus 2 plus 1 times the square root of x plus 2 plus 1 equals the square root of 3 minus x squared is 3 minus x. Alright, now I start to FOIL this. The square root of x plus 2 times square root of x plus 2 is x plus 2. The square root of x plus 2 times 1 is the square root of x plus 2. And look, that's always going to happen twice. 1 times square root of x plus 2 is square root of x plus 2. Now, instead of writing it twice, let's just go back and just say, okay, that's actually just 2 of those, right? So that's 2 square roots of x plus 2. So I can save myself a step. And then finally, 1 times 1 is 1. Alright, so again, this 2 square roots of x plus 2 came from the square root of x plus 2 times 1 plus 1 times the square root of x plus 2. So I have 2 of them. Let's clean up this left side. X plus 3 plus 2 square roots of x plus 2 equals 3 minus x. Okay, so now I need to isolate the root. So I'm going to subtract an x from both sides. And I'm going to subtract this 3 from both sides. Now I have 2 square roots of x plus 2 equals 3 minus 3 is 0, and negative x minus x is negative 2x.
Don't you mean plus x?
Yeah, it's supposed to be.
So now that I have a 2 out in front of this root, I'm going to divide both sides by 2 to get the square root of x plus 2 is equal to negative x.
Square.
Now both sides need to be squared. So that'll knock the radical sign off the left. So now I have x plus 2 equals negative x squared is x squared. Okay, I have an x squared and an x, so I'm going to have to factor this. To factor, I need to get everything on the same side. So I'll leave the x squared where it is and say 0 equals x squared minus x minus 2. What two numbers multiply to negative 2 and add to negative 1?
That'd be 2 and a negative 1.
Yeah, so I'm going to bring this up here so we have some room. So 0 equals x squared minus x minus 2. So 0 equals x minus 2 times x plus 1. Okay, so my solutions before checking them are x equals 2 and x equals negative 1. Okay, so now it's time to check to see if either of these are extraneous. So I'm going to check 2. That says the square root of 2 plus 2 plus 1 is equal to the square root of 3 minus 2. Well, the square root of 3 minus 2, this is the square root of 1. Look at this left side. Is this going to be smaller or the same as 1? No, like we have the square root of 4 plus 1.
It's 5.
It's 3. So the square root of 4 is 2 plus 1 is 3. That doesn't equal 1. So 2 is extraneous.
Wait, how is it 3? What's 3?
Square root of 4 is 2 plus 1.
Yeah, not 4 plus 1, but square root of 4 plus 1. Oh.
Okay, so now let's check negative 1. Because they both could be extraneous, but we have to see. Negative 1 plus 2 plus 1 equals the square root of 3 minus negative 1. Okay, negative 1 plus 2 is 1, so this is the square root of 1 plus 1 equals 3 minus negative 1 is the square root of 4. Well, that's 2 equals 2. Negative 1 is my only solution. All right, and that's how we'll solve if we have radicals or two radicals in the same equation.